T1 is equal to A, which is the first term. Then the constant ratio is equal to R, which means we are multiplying by R to get the next term. So if A is the first term, then what is the second term? We multiply by R, so we get AR, right? And then what is the next one after AR? It's AR multiplied by R again, which gives us AR squared, right? Multiply by R again, you'll get AR to the power of 3. I think you see the pattern, right? Okay, so this is the first term, this is the second term, this is the third term, that is the fourth term. We are obviously interested in something that will be in the nth term for our general rule. What is T5 equal to? AR to the power of 4, right? What about in position 20? What is the 20th term? AR to the power of 19. What about in position 100? AR to the power of 99. So what is in position N, the nth term? It should be AR to the power of N minus 1. Okay. And that would be a general rule, really. So Tn is given by A times R to the power of N minus 1. So this is your general rule. Okay. Let's build such a pattern ourselves. Let's start from a negative 3. I want us to, so A is negative 3. I want our constant ratio to be negative 2. Right, so if A is negative 3, then what is the next term? The next term will be 6, right? And what will be the next term? Minus 12, followed by? Yes. So followed by 24. Give me the last one. Minus 48. Right. We can stop there. I think you can see the pattern. And then when you get a pattern like this, you obviously need to check whether this is arithmetic, in other words, linear, or geometric, in other words, exponential. And so I know you'll start by maybe subtracting to check if there is a constant difference. Like 6 subtract negative 3 will give you 9. Then negative 12 subtract 6 will give you negative 18. Then 24 subtract negative 24 will give you 36. You might not see a pattern there. And so you might say, okay, let me try ratios. What is 6 divided by negative 3? So it's a minus 2, right? So if I take 6 and divide by minus 3, I get a minus 2. What is minus 12 over 6? Negative 2. What is 24 divided by negative 12? Negative 2. So you see we have a constant ratio here, right? And the formula for finding constant ratio, what would you divide Tn by in order to get R? Like here we divided T2 by T1. You could divide T3 by T2. You could divide T4 by T3. So in general, you are dividing Tn by Tn minus 1, right? Okay, so this is the method for finding this. This one is going to be very important, especially when we get to finance. You may need to know right now that in metric, we shall be using this formula. We shall be using that formula there to work out what we call annuities and so on. Right. Okay, so let's go back to the number pattern. So given a minus 3, 6, minus 12, 24, and so on, we want to work out the general term. Right, so first of all, you will check whether this is a linear pattern or not. I think we now know this is a geometric pattern. So and r is equal to negative 2. So if you want to find Tn, you can just put that into your formula, and the formula is given by Tn equals A multiplied by the ratio to the power of n minus 1. What is A in our case? A is negative 3. If you are not sure, guys, put these negative numbers inside a bracket. And what is the ratio equal to? It's a negative 2. Clearly, this has to be inside a bracket. And that is all to the power of n minus 1. Okay. Can you simplify that? Can that be simplified? Yes or no? Yeah, you can, but I think you can leave it like this. I hope you are not going to multiply negative 3 by negative 2, right? Because we cannot multiply the bases. So yeah, this will be the answer, guys. Suppose we go on to say find T, maybe T9. So to work out T9, what do we do? How do we get T9? Yes.
Substitute the 9 into n.
Yeah, so just replace n with 9. So this becomes negative 3 multiplied by negative 2 to the power of 9 minus 1. And you can work that one out. I think you will need your calculator there. Otherwise, I'll just leave it as it is now. It's negative 3 multiplied by negative 2 to the power of 8. Okay, that's fine. Leave it there. Remember, this is the general term. And we want to know whether negative 192 is a term in this particular number pattern. Any suggestions? Yes, come.
Plug in negative 192
Plug in.
or negative 192 by Tn, and then you're just gonna solve it like
Okay, good. So yeah, this is just another way of telling us that Tn is equal to negative 192, right? Right, so if Tn is equal to negative 192, check whether Tn can ever be equal to negative 192. So this is the case where you are looking for n. So you need to solve for n. So you form your equation. Tn is negative 3 multiplied by negative 2 to the power of n minus 1. And all that now we are saying, let's put it equal to negative 192. Right, this will help us to answer the question. If we can find n, and n must be a natural number, a counting number, then it means negative 192 is in the sequence. Right, what is the first thing you do? We are trying to work out n here. Yes. Divide by negative 3 both sides. Please do that. Divide by negative 3 both sides. So the left-hand side will remain negative 2 in brackets, all to the power of n minus 1. What do you get on the other side? You get is 64. Positive 64. Okay. And then right, so you then make them the same bases, right? What is the base on the left-hand side? Is that a 2? That's a negative 2. So we need to try and make that one a negative 2 as well, because the base here is negative 2. Right, so this is negative 2 to the n minus 1. So we need to write 64 as negative 2 to the power of something. What is the exponent? Is it 6? So that will be 6. So if the bases are equal, then the exponents must also be equal. So it means n minus 1 should be equal to 6. So you can just drop the bases now. And what do we get n equal to? So n is equal to 7. So what does that tell us? This means the 7th term in the pattern is actually negative 192. 92. So yes, minus 192 is a term in this particular number pattern.